Hello, thank you so much for joining us for today's webinar. My name is Lynn. I'm a customer service rep here at WarmlyYours, and today I am joined by my co-host.
I'm Scott. Thanks for joining us today, everybody.
Yeah, we're super excited today to talk about pairing electric floor heating with luxury vinyl tile. I know it's a very popular topic, so we have a lot to go over today. If you have any questions, feel free to ask either in the sidebar chat or at the bottom of the screen. If we don't get to them right away, we'll definitely address them by the end of the presentation.
Yeah, grab your popcorn and your soda pop, and you'll be ready to go.
I think, yeah, we're pretty entertaining. I think that's fair. So today's webinar, like I said, we're going to talk about floor heating, what systems we recommend for going underneath vinyl, and some, overviews of our floor heating products. We're also going to go over a project example that used our temp zone flex roll. We'll show you that installation process, and then we're also going to talk a little bit about the actual project cost. So LVT is becoming very popular. It's going to give you the look of a lot of other more expensive flooring types without the cost. So it's a very cost-effective way to update spaces in your home. It's also very durable. It's very scuff, stain, and scratch resistant. So if you have kids or pets, anything like that, it's going to hold up very well over time. Often can be anywhere from 20 to 25 years that it'll be in your home. So it's very sustainable as well. And when you're going to have something that you're putting in for a couple decades, it's always nice to have that little bit of extra comfort added to it, so you have that for a long time to come.
Yeah, they add that extra bit of comfort, and we get a lot of questions ahead of time. So we thank everybody for asking and sending those questions in when you get your invitations. Chuck, right away off the bat, wanted to know what's the point of heating a well insulated LVP floor. Well, the answer to that, Chuck, is do you want a floor that's warm or you just want a floor that isn't cold? Because there's a big difference there. So you are literally talking about a floor that isn't cold, maybe 68 or 70 degrees, where if you want to warm it up, you can get it up to 80 or 81, whatever the maximum temperature allowed by the LVT is. So you're looking at, anywhere between 10 to 20 degrees difference. So that's up for the individual to choose. Do you want a floor that feels not cold, or do you want to feel a floor that's warm? And I think the most of the people here are watching today because they want to warm that space up, especially in a basement. So that's where you want to do that with LVT.
Yeah, absolutely. It makes it really nice and extra comfortable. So we have a few different types of floor heating available here at WarmlyYours. So when you're shopping for a electric floor heating product for underneath LVT, you want to look for something that is able to be embedded. So that would be our temp zone products, either our flex rolls or our loose cable that can be kind of strung back and forth across the floor. So you want to make sure that you're steering clear of our Environ flex rolls. Those are designed more for floating floors. So you're looking for something, like I said, that can be embedded in self-leveling. And we're kind of going to go over a little bit more in depth why that is.
Yeah, and the thing is, it's all based on the recommendations of the vinyl plank manufacturer. When you see the word vinyl in the title or in the label of what this product is, that's what makes it different from laminate or what makes it different from engineered wood. Because it has vinyl in it, we're going to get into why vinyl is such a big deal a little bit later. You'll see why. But there's a reason why we don't suggest using floating installations with the LVT, and it primarily is because of the warranty restrictions placed on heating by the manufacturer of the LVT. So that's what you need to do is when you're interested in shopping for this kind of LVT, you're going to be wanting to ask specific questions of the manufacturer. What is the maximum temperature allowed? Because some companies will say 85, some will say 82, some will say 81. Whatever that number is, you have to keep the temperature below that to comply with their warranty. Also, another thing they'll say is whether the heat needs to be embedded or not. Embedded means that it's covered with self-leveling with electricity. So that's one thing you need to look for. You need to look for the word embedded. You also need to look in the installation instructions and the warranty coverage to see if there's a distance from the heater to the actual LVT specified. A lot of instructions that we see for LVT say the heat must be separated from the LVT by half an inch. which means they're looking for an embedded product. And usually it'll say embedded in the instruction manual. Also, they have flatness requirements when it comes to installing the floor. They will say that this floor must be installed with a flatness requirement of this amount per 10 feet or this amount per 6 feet. If you use a product like Environ, which isn't flat, it has wires running through it, then that's probably not going to couple along with your flatness requirements. So we didn't just make this stuff up and say, hey, let's present this. There are reasons why we're saying this, is because we've looked at a lot of installation manuals. We can't see every installation manual there is. We can't keep track of every installation manual when it comes to all the products that we sell. But what we can do is we can tell you, here are the things you need to look for in your particular product that you're interested in. And you'll also want to know what the R value of the LVT plank is, because you'll see a lot of LVT planks with pre-attached pads, and that is going to answer what question is that going to answer, Lynn? We have a question.
It was from, I need to find my question list.
Oh, number 7 from Mark. Mark said, can our product be installed under LVT with attached padding? And first of all, attached padding depends on what kind it is, but the overall rule is the R value of the LVT should have an R value of 1 or less. That's what you're looking for. The thicker the padding is, the more insulating it usually is. So if you get a really thick pad, you start to ramp up the R value. That's what you're looking for, is an R value of 1 or less. So that's another question you're going to want to ask your manufacturer, because that's what you're going to want to find out.
Yeah, absolutely. I think a big thing you'll hear us say today a lot is talk to your manufacturer. It just varies so much depending on, I've even seen it vary depending on color for the manufacturer. So it really is important to be chatting with them and kind of, in communication throughout the project.
In the early days of LVT usually wasn't as stable. I go to a lot of floor shows and I talk to a lot of the tech guys, and they'll say whether their floor can be heated or not. And you'll get into conversations with other people and they'll go, well, those guys don't want you to do this and those guys don't want you to do that. So it's all that kind of stuff that goes on in shows. But a lot of them say, LVT isn't quite as stable chemically wise when you start changing thicknesses and changing colors, just like you said. So that's why you always have to ask the manufacturer, hey, is this going to be good with radiant heat?
Absolutely. So we have a really good cross section here. It's going to really give you a good idea kind of what you're looking at for your installation process. So if you're installing on a concrete slab or concrete subfloor, which is what they did for the project example we're going to be going over today, first you want to put down an insulating underlayment. We offer a product called Cerazorb. It's a synthetic cork that you'll thin set down to the slab, and then from there you would lay out your temp zone, embed it in that self-leveling, and then lay out your LVT.
Yeah, so a lot of people watching today may not be going over cement. Some people, I think, somebody asked a question about a cottage setting that doesn't have a basement. Well, if this were on a wood subfloor, because that's just the way it is with some floors. If it's a wood subfloor, you would obviously from this drawing delete the concrete subfloor, and you would delete the Cerazorb, because Cerazorb really isn't needed over a wood subfloor. Cerazorb is there to isolate the wire from the slab, because if you put the wire directly on the slab's going to pull the heat down and try to heat the slab before it releases the heat going upwards. So that's why you never ever install electric heating cable directly on top of a slab. That's why the Cerazorb is there. Then another question somebody will ask is, why don't you use cork there instead of Cerazorb? What's the difference between Cerazorb and cork? Well, Cerazorb has twice the R value of cork, the same thickness, and it also is a synthetic product, which means if it's in a basement and it gets wet down there every once in a while, cork is a natural substance that mold can eat, whereas Cerazorb is a synthetic product that does not provide dinner for the mold. So it's very, very important that you keep that in mind. So it's not something you want to do. And also the other reason why I found this out about 15 years ago when I first started here, someone had used cork and then poured self-leveling over it, and the cork just went vroom like that, because cork expands when it gets wet. Cerazorb doesn't. So that's why we're saying Cerazorb in here. If this were an installation over wood, we would have thin set covering the, no, we wouldn't. We wouldn't have thin set at all. So we would just simply be putting the temp zone flex roll on the wood subfloor and then attaching it very, very well and then covering it with a 1/2 inch of self-leveling cement. That will give you the flat floor. So you don't need the concrete here, you don't need the thin set, and you don't need the Cerazorb if you're doing a installation over wood.
Yes, awesome. So, Scott, this is definitely in your wheelhouse. Can you tell us a little bit more about why we are embedding this product versus using a floating floor just going directly over it?
Well, you can see that the LVT is getting sad. As each picture from top to bottom, it just gets a little more sad. It frowns a little bit more over time. And what that is this is a perfect illustration of drape. LVT has drape. Drape means it starts to conform to what's under it. So if you took a look at I'm going to go back. I know some people don't like it when I go back and forth, but I just want to make sure that people see this Environ flex roll here. You can actually see the wires going back and forth, and you wouldn't want to set the LVT directly on that because after a while, you can picture that white block in the middle as being the wire, and the LVT would conform to the wire over time. So you'd see all these waves in the floor. That's another reason why you use self-leveling, because it's going to give you a flat floor that you are not going to see waves and undulations in the flooring. So that's the difference between laminate and LVT. Whether the LVT is stone core or whether it is all these other polymer cores or any of these other cores, when you see the word laminate, not laminate, when you see the word vinyl, you need to worry about this frown and turn that frown upside down, because that frown is because of drape. So that's one thing, and that's why it's the root of most of our installation requirements, besides the instructions from the manufacturer. So check your flatness requirement, make sure that you comply with that, and watch out for the drape of the LVT.
Awesome. So when looking at an LVT or an LVP and kind of picking out which product you're going to use, you want to find one that has no or very minimal backing. And I know we kind of addressed this earlier, but a little bit more in depth. One of the things to be looking for is that the entire assembled plank has an R value of less than 1. And when talking to that floor manufacturer, just making sure that their product is compatible with in-floor radiant heat, and asking them, like we said earlier, about the maximum temperature and that setback temperature.
Right, the setback temperature, for people that aren't familiar with that on a programmable thermostat, the setback temperature is the temperature that you would set it to like in the middle of the night when no one's on it, or in the middle of the day when everybody's at work. So there's no need to heat a floor normally with tile when there's nobody there, so you can drop the temperature to 68 or 70, whatever you want it to be. But some of these manufacturers of this product say you are only allowed to deviate from, here's the max temperature, this max temperature may be 82. You're only allowed to deviate 2 to 3 degrees per day with this product, which means you're going to be going from 82 down to 79. It's really not worth doing all that programming for 3 degrees. You just set it to the maximum temperature or a degree less and let it run. So that's what a setback temperature is. You want to ask the manufacturer if they allow setback temperatures, and if they do, what's the limit? Is it 10 degrees? Is it 3 degrees? Is it 15? They don't care. That's what you need to find out, because if they say there's no setback temperature, that'll determine the thermostat that you're going to purchase. We're going to talk about that in a little bit. So hopefully that answers that question. And we also need to talk to a question from Richard when he asks, will we need to install a barrier between the mesh and the LVT? And the barrier is the self-leveling. It's letting the heat through. It's just providing that 1/2 inch required barrier distance-wise. You never want to put anything with R value between the heat and the floor where your feet hit, because it doesn't make any sense. If you're going to this expense and trouble to buy a floor to warm it up, the last thing you want to do is put a blanket over it or something that's going to block the heat from going to where your feet are. So you need to keep that in mind. So hopefully that will answer your question about that, Richard. So very, very good question. So that's one of the things you want to look at when it comes to these LVT planks. Watch out for the R value. That's very, very important.
Awesome. And then kind of in that same vein, looking at the temperature limit for LVT, you want to make sure that you are setting that maximum temperature on the thermostat correctly. One of our settings that's very popular is laminate. It maxes it out at 82 degrees. That's a pretty common maximum temperature. Or again, you can use custom and set that custom maximum temperature yourself.
Now, the only way to limit your floor temperature is to put a thermostat sensor in the floor. So you need, if you're not interested in buying a WarmlyYours thermostat, you need to make sure you find one that, or you need to protect the floor with GFCI protection, which is done with our thermostat. So you get that when you buy one of our thermostats, you get the GFCI built in. And you also need to get one that has a sensor that you can put in the floor. If you look at a lot of low voltage thermostats, I'm going to say brand X, which is really, really popular out there. It's round. There are a couple of round thermostats out there, and they have leaves on the front and everything like that. Those thermostats normally don't have a floor sensor input. So if you're interested in using a different thermostat than what we sell, you need to make sure you provide GFCI protection to the floor. And you also need to find a thermostat that has a thermostat input for a sensor. So you need to be able to put a sensor in the floor if you're going to comply with the warranty requirements of the max temperature set by the manufacturer of the LVT. So you can't just buy a thermostat because it looks cool. You need to buy one that looks cool and it has a floor sensor input. Very, very important when it comes to this product.
And we're always happy to help if you are looking at a potential thermostat and you're not sure if it would work. Just give us a call and we can definitely walk you through it. So our project example used Tempzone flex roll on concrete subfloor, like that cross section we showed earlier, and this was done in a bedroom/office that was in a basement in Toronto. So the first thing you're going to do when you're kind of planning a project like this, or the first thing we recommend doing, is reaching out to us for a smart plan. It's going to look something like this. You can just send in a drawing with the dimensions of the area that you want to heat, and we will send something that looks like this back. And it's actually going to show you which products we recommend, what size flex roll, and then we're also going to show you exactly where to cut and turn it, and the exact coverage that you're going to get. And then one thing to point out is that the perimeter of the room is generally not heated. It doesn't usually need to be. You're not usually standing with your feet directly up against the wall. So that's just one way of many that we can, kind of work with you on the smart plan on, making sure that you're getting the coverage you want and the layout that you want. We can always play around with those that perimeter as well.
So you really need to, when you're doing these installations, it's the more information you can get, the better. That's why we bother doing these webinars, is because we want you to make an informed decision as to what brand of product you buy. Make sure you buy the right stuff. If you notice here, you can see on this drawing, it says, please verify dimensions. And that means once you get the drawing back from us, please make sure that the dimensions have not changed, especially if it's a new construction job where it's, we decided to put a closet over there. Well, if you put a closet over there, now all of a sudden the available square footage on the floor has been reduced, and usually been reduced by a lot, which means the product that we are quoting you is probably not going to fit. So if your dimensions change and you add things to the room, when you add things, you are removing available floor space to heat. So the product you are spec'd is probably going to be too big. The thing with this electric product is you can never cut it. You cannot cut the heating wire. So you can't just buy a gigantic spool of this stuff and just go, I'm going to use this much and I'm going to cut it off and then we'll be good. You can't do that. You need to make sure that you get the correct size. And remember, when you're doing an installation like this, a little too little is better than a little too much, because you can always kind of rearrange if you have a little too little to put it where people are for sure going to walk, and kind of take it out of areas where people don't walk, which means pull it away from the walls a little bit. But if you have too much product in the room, there's nowhere for it to go. So that's why it's so important to verify the dimensions of this product. Also, when you give us a plan, make sure you mark where the thermostat location is, so we know where to start the product. So that's where that T is in a circle over here. That's where the thermostat is. That's where the product starts. And the triangle on the roll itself is the start, and the square is the end. So notice how the triangle is always located as close to the T as possible. The non-heating leads are 15 feet long, so if you need to move it over here, it usually isn't that big a deal, but you have to remember 15-foot long cable, but is usually 5 feet up the wall and hanging out some. So it really needs to be within about 10 feet of where the product triangle is on the product itself as opposed to the T. So you really need to watch out for that. So it's very important to get us the correct dimensions. And also think about what you're trying to do with this product. Are you using it for sole source of heating, which means there's no air vents in this room? This is the only thing supplying the heat? Well, if this is proposed to be the only thing supplying the heat, you need to do a heat loss calculation. And that heat loss calculation is on our website, and you can find out if your available square footage is going to generate enough BTUs to heat the air in that particular space. So when you're thinking about sole source of heating in a room, there's also one other little quirk you want to think about, especially when it comes to what people are always asking us. I want to make a 3-season room. So I want to make a 3-season room on the back of my house. What product should I use in that 3-season room to make sure I get some good heat in there? Well, if you were asking me, I would use a product that has no temperature limit, which means a product like tile. Because if you have to run tile at 100 degrees, that's fine. It's not going to do anything to the tile. The last thing you want to use in a 3-season room like that is something that's limited. And that would be this product under LVT, because it can only get to 82 or 83 or whatever it is. So it can only get up to 82 degrees. That may not be enough warmth to make that space warm. Whereas a tile that you can set to 100 or 99 or whatever it'll get to will generate more heat, will pass more heat into the room. So you want to think about sole source of heating, and if it is, you try to maximize the heat in that space by using a product that doesn't have a temperature limit. What are some products that have temperature limits? Carpet, LVT, laminate, stuff like that you want to watch out for. So that is going to be, I want sole source of heating, do a heat loss calculation, and also choose a product like tile that's going to allow you to heat that space a little bit better. I didn't want to go off on that tangent, but those are kind of the questions we get all the time. So it seems like it may be a good idea to kind of share that here while we're talking about plans and filling the space and that sort of thing.
It's good information to have, absolutely. So looking at this project overview, like we said, they used the Tempzone Flex Roll. The total area of the space or the room was 164 square feet in the area that they heated. Obviously, we saw that perimeter, that non-heated perimeter and things like that. So they actually heated about 129 square feet of that space. The wattage was 1,935 watts, 8.1 amps. Then it used a dedicated 15 amp, 240 volt breaker. Non-GFCI, we'd kind of talked about that earlier. So just make sure that you are looking at those power requirements and utilizing the correct breakers for your size project. And the operating cost for this was about 8 cents an hour. So like we said, this was a home office. They're probably running it about 8 hours a day. So you're looking at about 67 cents a day to heat that space.
So very important that you do not have a GFI breaker. It needs to be the regular old-fashioned breaker, once again, because the GFI protection is in the thermostat. Also, by pulling the heat away from the walls where you really don't need it, you're saving upfront costs of purchasing it. You can see we heated about 35 less square feet by doing that. So it's going to cost you a smaller amount. You buy the size that's 35 square feet smaller. And then when it comes to running it, instead of heating 164 square feet, you're heating 129. So it's going to cost you less to operate also. So that's why we go to trouble with these things and try to explain why we do what we do, because it's going to measure a good heat output and not give you stuff that you don't need. So that's what's so important when you're making a big decision like this on how you're going to do it.
Yeah, absolutely. So you want to make sure that you are testing your system, since this is going to be going underneath something permanent like self-leveling concrete. You want to make sure that you are putting in a working system before you cover it with that concrete. So we always recommend testing at every stage of that installation, testing it before, during, and after every step that you take, and utilizing 2 different products. So can you kind of tell us, Scott, what we're looking at here, the difference between the ohm meter and the circuit check?
Well, the digital ohm ohm meter is not an optional item. You need to get one of these before you install the floor. I'm old enough to remember when digital ohm meters cost hundreds and hundreds of dollars. They now cost 20. So there is no reason to use the analog meters with the needles on the front. Needles on the front are great when it comes to stereo amplifiers because it looks really cool when you're listening to the music, but they are not good when it comes to testing floor heating. So this digital ohm meter, under $20 at any big box store, and you want to make sure that you get the ones that let you choose different ohms ratings inside on the front with a knob on the front or a dial. You want to be able to choose 200, and you also want to be able to choose 20K, and those are the two especially important ones. The 20K reading is done for your thermostat sensor because you test your sensor too before you put it in the self-leveling cement. And you're going to test your product, and 90% of our product tests at the 200 range. So the problem is, the reason why we go to all this trouble to say that is because self-ranging meters, if it sees your sensor, probably isn't going to see your floor heat. Or if it sees your floor heat, it's not going to automatically reset to see your sensor. So the more you spend on a self-ranging meter, the more harm you're doing yourself. So it's kind of inverse like to what you would normally think of. I'm going to go get a good meter. Okay, the best meter to get for floor heating is a cheap one, not a $500 meter. You want to be able to select those numbers on the front using the dial. So you're going to test it the day you get it. So when you get the product delivered, make sure you test it. Make sure that it's good before you even before you go to do your installation, because if you test it the day of the install and you find out something happened to it between us and you, then you're saying, okay, hold on, everybody quit mixing that cement. We need to get a replacement unit because it's got, somebody dropped it somewhere, or 10,000 pound weight or an anvil fell on it. So you need to make sure that it's not damaged ahead of time. So you're going to test it before, then you're going to lay the product out. You're going to test it again to make sure that everything's good before you pour the self-leveling, and then you're going to test it after the self-leveling and the flooring is installed. But in between those times, you're going to be attaching the circuit check, because what it is a siren that tells you if you create a short or if you cut the wire and create an open, which means you have no circuit or you have a short circuit. It's always testing that, because if you're putting all this stuff down on the floor, you can't sit and hold the meter on the whole time, right? Because you got to go work over on the other side of the room. So what the circuit check does is it keeps track of that while you're doing other things. So if you're over there and all of a sudden you drop an anvil on the wire and the thing goes, brah, it starts screaming at you, whatever you just did caused the problem. You need to find out what that is and give us a call, and then you need to test it with the ohm meter. So that's how the two parts actually work together at separate times. You use one here, use one there. So the instructions that come with the product will tell you exactly when to do both. And the little label that's on your heating product, it's usually three labels, 2 or 3. And one is always located within 3 inches of the end of the cold lead, and it'll tell you what the ohms are. That number should match within 5 or 10% of the number that you're getting with your meter. So that's how these two are used, that's how they are required, and that's how you're going to have a good installation, by just following these simple instructions when it comes to testing.
Awesome. Yeah, that's really good information to have. I think it's always helpful to know specifically why you're doing those too, because we're not just telling you to test because we like making your life harder. We like telling you to test so that ideally your life is easier in the long run.
I've got a great idea. Let's go out and make them buy a meter that they don't really need. We're not like that. We're not going to sell you one either.
Let's say, since we're not selling it and we're not making you go to Walmart just for the fun of it.
Right.
So unless you're like me, and then you just kind of wander stores for no reason. So the installation process for this is going to be, again, very similar to the cross-section that we showed earlier. So we're going to walk you through it, starting with the subfloor preparation. You want to make sure that your floor is level. Obviously, the more level, the better, and Scott can kind of elaborate on specifically why, or maybe even the dangers of not leveling it first.
Well, let me just give you a story of one of the first 6 months or so I worked here long ago. Somebody called and they had just done a big installation of this product in a really old house from the 1850s. And they called up and said, I can't understand this. The center of my room is cold, but the outer edges are really hot. Well, I don't have a set of eyes. I can't see where they're standing. I don't have X-ray vision, so I can't see. Oh, I can see that you're standing in an 1860s house. I don't know that until they tell us what exactly is going on. And I'm thinking, why would the center be cold but the outer edges be warm? Well, that's because the room in the center is about 2 inches or 3 inches lower in the center because of age. It has turned into a bowl. And the thing is, the further away the wire gets from the flooring surface, the colder it is, the less it heats because it's further away. You want the top of your flooring to be within an inch to an inch and a half of the wire. That's why we specify 1/2 inch of self-leveling. The thickness of your product is going to put you right in that sweet spot. So the center of this room was about 2 inches, 2.5 inches deep, and the outer edges were 3/8 of an inch deep. So the outer edges were nice and warm, the center was cold, and that's what happened. That's why you self-level, you get the spot level first, and then you start working, because that keeps the wire the same distance from the top of your flooring all the way across the room. So very, very important there, and I'm glad you brought that up.
Awesome. So looking at then the underlayment as the next step. So first we recommend dry fitting that Cerazor, making sure that you'll be able to get the entire floor covered with it and you're going to know where you're putting, what down. And then you can just spread that thin set on the concrete slab, and you'll lay out the Cerazorb using a weighted roller to really help that Cerazorb adhere to the thin set. Make sure that it is going to be, on there really good. And then we do recommend lifting up the Cerazorb a little bit to check for the adhesion of the thin set, just to make sure that it is down properly and everything is looking good before moving on.
Yeah, make sure you use modified thin set to do
Yes.
this. Modified thin set is the job, is the product you want for the job.
Absolutely. So the temp zone flex roll stage, this is the fun stage, actually laying out the heat according to that smart plan. So you will lay it out with the cable side down. You want the mesh facing up, ideally just to, give that cable a little bit of extra protection. That way it doesn't, I don't know how much that mesh helps, but it definitely is better than just laying the cable up and kind of out for the elements. So you'll cut that mesh between the loops to turn the mat. Make sure that you are cutting the mesh and not the cable. And I think you will hear us say that a lot here. You never ever want to cut the actual heating cable itself. You want to cut that green mesh, and you want to cut in between, an open loop, so you're not anywhere near the actual heating cable itself. And then from there, once you've laid it out according to that smart plan, you'll attach it to the subfloor. Make sure that you are attaching it really well so it doesn't float up in that self-leveling. Self-leveling is incredibly dense, so anything that is in it tends to float to the surface, at least in part, and eventually you'll start seeing, some bumps and ridges on this surface that's supposed to be super smooth. So make sure that you are adhering this really well using, usually hot glue guns work really well. We've seen people do staple guns, making sure that you are stapling the mesh only and nowhere near the actual cable itself, or double-sided tape can also be used.
Yeah, the most important thing is when you're laying this product out, is to make sure it's wire side down, because that way when you attach the mesh very well to the subfloor, that's going to hold the wires down, because everything is going to try to float. So you're going to watch out for that. And if some of it does float, make sure that you just don't have somebody come in and go, there's some spots over there, I can see there are little bumps. Can you grind them down? Well, those little bumps are the heating wire that's floated to the top. And as soon as you start grinding heating wire, you're in big trouble, because you're creating a bad spot. So you don't ask me why we're bringing this up, because we get calls all the time from people who, oh, you know what, I forgot to attach it to the subfloor, and now it's all up here. The only cure for that is to then float another layer. So we're just trying to save you that misery of, grinding the wire away, or doing other things that aren't associated with making sure that it's held down very, very well. Hot glue is the best for that.
Absolutely. So, Scott, you know a lot about our sensors and specifically, why they are so important. Can you kind of tell us about the stage of the installation?
Well, yeah, our installation manual has a great, it has a picture just like this about how to put the sensor in. And just yesterday, I got a call from somebody who said, or an email, I took very, very good care and I made sure that I got that sensor out into the middle of the floor so I could sense the temperature while I'm going right. You don't want the sensor out in the middle of the floor. You want the sensor 6 inches into the edge. And that's a perfect place for it as long as it's not where the sun hits and it's not under a plant or something that's going to trap heat. So you need to watch out find out where the sun's going to be hitting this room and make sure the sensor isn't there, because that spot will be warmed by the sun. That floor will be really warm. So the sensor will say, oh, this is really warm. I don't need to turn anything on. Meanwhile, the floor on the other side of the room is 50 degrees. So you need to watch out for that. So it's very important where you put the sensor, and you don't need the sensor in the center of the room. You just need to get it somewhere where it's not getting hit by the sun, 6 to 8 inches into an open loop. You see the blue wire there? That's the wire that is attached to the mesh. You do not want to run it over the wire. You want to run it in the open loop, and that's what an open loop looks like. When you're doing this installation, please make sure that you don't go, hey, I've got the thermostat sensor box, I'll just save that later for the electrician. No, no, no. You need to open that sensor box, that thermostat box up, because that's where the sensor is. And you need to give it to the person who is laying the product down on the floor so they can put the sensor in just like this. Also, you need to make sure that the sensor wire never goes up the same conduit as the non-heating leads. That's against the National Electric Code, probably against your local code, and it's also going to make the sensor not work at all. So it needs to be in its own conduit, or if conduit isn't required for low voltage wires in your locality, then it can just run up the open space in the wall, but it cannot go in the same conduit. We're going to show you a picture of that here in a little bit. So that's why we bring this up, so we don't deal, and people say, well, why? I want to put this in the I want to put this sensor in the same conduit as the non-heating leads. I'm going to do that. Then all we can do is say, when those wires are energized, you're going to get induction from those high voltage wires, and it's going to obliterate the signal coming from the sensor. So that's why you don't do it, and this is what's going to happen. So always watch out for that, and we have a good diagram coming up here of that.
So looking at the self-leveling concrete stage, at this point you should have been testing your system. We always recommend testing it before actually beginning pouring that concrete as well, and then making sure, again, before pouring, that you have secured these really well to that subfloor, and then you can begin that self-leveling pour. You're looking for at least 3/8 of an inch to about a 1/2 inch layer of self-leveling. That tends to be, I think, the most common recommended, and that's definitely what we recommend for our product specifically. I know some flooring manufacturers do require a little bit more, or they say you could even do a little bit less, but we would always recommend at least 3/8 of an inch to a 1/2 inch.
Yeah, I've done a bunch of jobs like this, and the thing you want to make sure is that for the small jobs, you can probably do the self-leveling yourself or with a buddy. But if you're doing a room that's like 120 square feet or 200 square feet, you are definitely going to need a couple other people to do the self-leveling. You're going to be pouring the self-leveling on the floor, making sure that it's the right thickness, that sort of stuff, not using self-leveling tools. Okay, you don't want to use spikes. We just had a guy a couple weeks ago that wears spikes because he always wears spikes when he does self-leveling. Well, he had never done a floor heating job, and you can't wear spikes when you're walking over electric floor heating cable. That floor was damaged severely by the spikes damaging the wire. So you can't use spikes, and you can't use the floats that have the metal pins that you can use for height adjustment. You can't use those metal pins as you rake back and forth. You need to use a rubber squeegee to do this work over the top. So that's where you're going to be busy doing that. You're going to have somebody that's running the self-leveling back and forth, and you're going to have somebody mixing the self-leveling for you on these large jobs. So that's what you're going to need to plan to do. So if you're going to be doing a large job, it's going to be you and a couple of buddies, or maybe 3 buddies. If it's just you, then you might be able to, like in a 20 or 30 square foot job, you could probably do that yourself. Anything more than that, you need to make sure that you have some help. So those are just the kind of things we strongly suggest that you, if you've never done self-leveling before, to watch a couple videos online, because we know you can become an expert on anything by watching YouTube videos. until you find out that you that the 10,000 hours of practice really is better than a YouTube video. But anyway, so you want to watch out for that kind of stuff. Don't use the common self-leveling tools when it comes to working over electric heat.
And then moving on to the installation of the LVT, actually the flooring itself, which is kind of the fun part. So you want to make sure that that self-leveling has dried and that it complies with the moisture level requirements from the flooring manufacturer. So again, this is another reason why you want to be in contact with your flooring manufacturer asking these questions. And then we also recommend following all the acclimation requirements for that specific flooring and following all installation directions. So once you have properly installed that LVT, we know it's exciting and you really want to feel the warmth, but make sure that you are waiting to power up the system until that self-leveling has actually cured, not just dried, but actually cured. So you'll want to hold on to the packaging to check those cure times and make sure you're waiting the proper amount of time.
Yeah, and also one thing we almost forgot to mention is when you're doing self-leveling, you need to look on the self-leveling bag and see if a primer is required. Because if a primer is required, you need to use it. And the best time to put the primer down is to put it on the Cerazorb in this case. So you'd have the Cerazorb down, you'd then use the primer over the top of it, and then you would put the heating cable down. So people ask, well, should I put the primer down first and then the heating cable on top of it, or the heating cable down and then the primer over the top of that? You should put the primer down before you put the heating cable on top. Because remember, you don't have to really worry about any damage to that primer from the electric heat, because that wire is going to be surrounded by self-leveling. So you're not really going to have a really hot spot to worry about anything getting damaged. So you need to make sure that you use the primer that is required on the bag. Also, people go, oh yeah, just like you said, Lynn, this is going to be great. I'm going to turn it on now. Don't turn it on until it's cured, because you can damage the actual construction or the makeup of the self-leveling by heating it too fast. So that's one thing you really, really want to watch out for.
Yes, for sure. And then this is the drawing I think that you were referencing, Scott. Can you kind of show us the conduits and everything like that?
Yeah, you have the one conduit delivering power to this thermostat, and then you have the wires coming up one of the conduits to that 2x4 box, single gang box, and then the other conduit, if it's required by your local code, is for the low voltage sensor wire. So that's how that setup is done. So very, very important that you can do that. If you have a bunch of mats that or a bunch of rolls that you're going to be connecting together, what you can do is you can put a junction box down here at the bottom of the wall and run those multiple mats to that junction box, and then make a connection with one wire going from here to here, as opposed to trying to get 3 or 4 wires up that conduit and try to make multiple connections behind the thermostat. So if you have more than one mat, you can usually get 2 connections done in the back of a thermostat in a normal box. If you have more than 2 products, you need to make sure that you get yourself a junction box there at the bottom, so you can make your multiple connections there and hook it up to a piece of Romex and run the Romex up to the thermostat with your connections there. So you need to watch out for that. So that's how you want to do that connection. Also remember, the thermostats can only handle 15 amps. That's all they can switch, which is about 120 square feet when it comes to 120 volt product, or it's about 240 square feet when it comes to 240 volt product. So it makes it easy to remember at 15 watts per square foot. That's a good guideline. So if your floor is over 120 square feet, you're probably not going to be able to attach that to one thermostat. So please keep that in mind. The thermostat can only switch 15 amps at a time.
That's definitely a good point. And if you are unsure if your project is 15 amps or more, obviously you'll probably know if you've gotten a smart plan from us. We'll show you which, we'll tell you if you really need to get like a power module or something like that. But if you're unsure, just reach out and we can definitely help you figure it out. And then looking at the actual thermostat itself, again, making sure that you are aware and setting the temperature limit. I know I kind of feel like we've beat that horse, but I'd like to make sure that we're all aware of the temperature limits. There's no point in damaging your nice new floor just because you weren't aware of something small like that. So you can, depending on which thermostat you get, the temperature limit setting is going to be a little bit it's different depending on each thermostat, but each one is pretty simple. We usually recommend going with our Inspire Touch thermostat for the majority of projects. But Scott, like you had said earlier, if there's something that you really are just going to set it and forget it, and you don't need to be changing that temperature or programming it in any way, the Entrust is a really good one for that. It's just going to be basically on off and let you control the temperature of the floor.
Yeah, it's kind of similar to doing hardwood. I did a really big
Mhm.
heated hardwood floor here locally a few years ago, and that hardwood floor has kind of like the same rules when it comes to LVT, a maximum temperature. It is also not allowed to have a setback. So what that homeowner does, because a setback is not allowed, it has to be kept within 2 or 3 degrees each day, is at the beginning of the heating season, if the floor is starting at 66 degrees, they set the thermostat for 69. Then the next day, they set it for 72. Then the next day after that, they set it for 75. And they go up 3 degrees every day until they get to the maximum temperature, which for their floor, I think was 82. And then it stays that way forever until the end of the heating season. And then they go from 82 to 79. Then wait, and the next day, they go 79 to 76. And then the next day, so on and so on. So always keeping within the 3 degree rule. And I've been over to that house just recently in the middle of the winter during heating season. There's no gapping going there. There's no problems with the floor whatsoever, because the floor during the winter is at one temperature the whole time. So it's actually subjected to less temperature fluctuation in the winter when the heat's there, because the heater keeps it the same temperature all the time, as opposed to the summer when the room is 80 degrees, or if the room is 75 degrees or whatever. There's more contraction and expansion in the summer with humidity and all the other stuff that goes on than happens in the winter. So that's one thing you really, really want to look out for. And it's kind of funny, the most expensive floors require the least expensive thermostat, and that is the Entrust. That's the set it and forget it. No setback. You set it and it will keep that temperature forever until you change it again. So that's what you really, really want to do. And the key with the Entrust is it has a floor sensor. You need to make sure that you get that floor sensor installed.
Absolutely. For all of them, make sure that we're getting that floor sensor installed. So looking at the finished project, I think it looks awesome. It's a beautiful floor. It's a beautiful room itself, and that's going to be nice and comfortable, especially with it being in a basement. I know basements are often hard to heat. It's hard to push warm air down below the surface. So having air that's going to, or heat that's going to be rising itself and heating that room itself, it's a nice way to make that a little bit more comfortable.
Yeah, we had a question from Joe. He asked, how well does LVT stand up to roller traffic from an office chair? And there's an office chair right here in this picture. That is a question you'd have to ask your LVT manufacturer, because we're just supplying heat. I don't know how well their product stands up to rollers. They should be able to answer that. They may have even done a Robinson test, which a Robinson test is kind of like one of these chairs, only instead of it going back and forth, it just goes around, 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 and around. And it does it thousands and thousands of times. And it'll tell you what kind of a Robinson test result that particular flooring has. So we can't answer that question, but at least give you an idea that you should ask the LVT manufacturer if they have a Robinson test, and if it's Robinson tested, is it commercial, is it light commercial, is it home, whatever that is, and they will give you an idea whether it can stand up to rollers on the chair or not. So very, very good question. Thank you for asking that, Joe.
Yes, thank you. It's something you never really think about until until it's too late and you've gotten your floor damaged. So the project cost for this total came out to $2,549 MSRP. So again, they used that 240 volt flex roll, the Wi-Fi thermostat, circuit check, and Cerazorb. All right, awesome. So that's all we have. Are there any questions or anything? Did we go over all of our previously asked questions, Scott?
Those are all the questions we had submitted ahead of time.
Awesome. So while we kind of finish up, we have some housekeeping things to go over. If you think of any questions, feel free to continue asking them. We are more than happy to continue chatting. So our next webinar actually is talking about wood floors. So that'll be on Thursday, June 9th, again at 1 p.m. right here on Crowdcast. So feel free to join us for that. And we also have daily trainings. So these are, again, here on Crowdcast. Generally, we have them at least once a day, sometimes twice a day, often hosted by me or Scott. So they're just usually short 5-10 minute trainings about whatever topic du jour is. And if you are, interested in something in particular, you can always hop in and we're happy to talk about really any topic. It doesn't even necessarily need to be the presentation for the day.
Yeah, we do these on Facebook too.
Oh, that's correct. Yes, thank you. So the monthly promotion for May is 20% off of our lava radiant heating panels. These are basically the new age, the new fancy radiant heating. What's the word? Space heaters. That's it. A lot safer, a lot more comfortable, warm, natural feeling heat. So if you're interested in our radiant heat panels, feel free to check those out.
Yeah, like 10 years ago, I was at a friend of mine's house, and I asked her, I said, do you have heat? Beautiful tile floor in a 3-season room. I go, do you have heat under here? They go, you can heat tile? I go, yeah, that's what we do. we actually heat tile. Well, what can I do? Because I don't have, I can't, I don't want to lift my tile up and do it over again. So then we go, well, we should probably sell products like this for people that didn't know that floor heating was available. And these are great for people that missed the boat, that didn't realize that we had floor heating, or in rooms where they need a little bit of extra BTUs, maybe a bathroom, that doesn't have an air vent or something. So those are great products for people that have missed the boat when it comes to floor heat, or just need a little more oomph in that room to get it nice and warm.
Yes, absolutely. Yeah, there's a lot of people that are, not interested in tearing up their floor, so it's a good option there. So we'll be sending you an email shortly after this asking about your experience today during the webinar. We would love to hear your comments and suggestions. We want to make sure that we are, we're doing these for you. So if there's a topic in particular you want to learn more about, or there's something that you'd like us to do differently, or that you really liked that we did today, let us know so we can make sure to tailor these for you. And of course, we've said it many times, we are here if you have questions. We do offer 24/7 technical support, of which Scott is a large part, and we are more than happy to answer questions and make sure that you feel confident with your product and going into your installation job. So give us a call, shoot us an email, and of course, our website has a ton of information. It's a treasure trove of anything you could want to know about heat, essentially. So feel free to check that out as well.
Lots and lots of videos. Lots of videos. And one thing to keep in mind is we kind of made a joke about YouTube videos, how everybody becomes an expert after you watch a couple. The videos that you watch are never a substitute for the installation manual. So whenever you're doing one of these jobs and you go, man, I'm wondering what should I do here or what should I do there, even if you're not buying the product, all you need to do is let us know. We'll send you the installation manual, or you can find it on our website. We'll be glad to send it to you, because that will answer all, it's the source of information about the product. So if you look at that, and it's not War and Peace either. I mean, I had to read War and Peace in high school. It was like 600 or 800 or 900 pages, whatever it was, because I grew up in Indiana, and the guy that wrote War and Peace is from Indiana, General Lew Wallace, I think, or is that Ulysses? I can't ever remember because I faked reading both of them, so I hope my teacher's not watching.
I will say I don't think either of those are it, but I have no idea.
So I think Lew Wallace was from Indiana. I can't remember. Let's not get on that tangent.
So thank you so much for joining us. Obviously, we always have a ton of fun doing these, and we love having all your questions and knowing that you're getting some information out of this. So until next time, we hope that you will stay warm
And be radiant. Thanks, everybody.
Bye. Thank you.